Hello everyone. Today I am going to talk about parallel and perpendicular lines and also reflections, the stuff we covered this last week in geometry. So first we're going to talk about parallel lines. I've graphed a line with the equation y equals negative 1/3 x plus 4. So once again, that tells us that the slope is negative 1/3. So if we go down 1 over 3, we'll get to another point on the line, and our y-intercept is at 4. So now parallel lines, they have the same slope, and they will never cross. So if I make a point at 0, 2 for a y-intercept, and then I go down 1 over 3, down 1 over 3, down 1 over 3, and I make that line. Not quite perfect, but you get the general idea. Those lines are parallel. They have the same slope and they will never cross. Kind of like railroad tracks is a good example of parallel lines. Next, we're going to talk about perpendicular lines. Now, perpendicular lines are a little different. They have opposite reciprocal slopes, and they form 90-degree angles when they cross each other. So once again, the original slope for this one was down 1 over 3. So to get the slope for a perpendicular line, we do the opposite sign. So it was negative. Now it's going to be positive. And then reciprocal means we flip it. So it was negative 1/3. 3 was on the bottom, 1 was on the top. 3 goes on the top, 1 goes on the bottom. And it was negative. Now it's positive. 3 over 1 can also just be written as 3. So now, if I start with any point on this line, so I start at 4 again. If I go up 3 and over 1, I can also go down 3, back 1 to draw in a perpendicular line. And then the key, the way to check to know you make sure or you did it right, is to check that all 4 angles are 90 degrees. So with perpendicular lines, opposite reciprocal slopes, and you're going to form 90-degree angles when they cross. Last thing we're going to cover today is reflections. So with reflections, it's like if you were to fold over a line, it would match up perfectly. So I've got a little triangle drawn here. And I want to reflect that triangle across the y-axis, or this green line. So if I would fold it over the green line, it would match up perfectly. In order to do that, you can either see what would happen or you need to count to line. So going to the line, the green line from this point, I go 1, 2, 3, 4 units to get to the line. So I need to go 4 boxes over here to get to the other point. This one I go 1, 2, 3, 4, so 8. So I would go 8 over here to get to the other point. 1, 2, 3, 4, 5, 6, 7, 8. same distance. So reflecting over that line, you would get that triangle. So reflection, if you fold it over a line, would match up. So when it's over a line that's straight up and down, or straight side to side, much easier. Next, I'm going to show an example of reflecting over a diagonal line. So now we're going to reflect over the line y equals x. To do this, we need to form perpendicular lines with each point to the line of reflection. So if I go through the boxes, I go 1 box, 2 box, 3 box, 4 box, and if you notice, formed a 90-degree angle. I need to go that same distance on the other side of the line to get where that point would be. If you notice, those two are the exact same length and both form 90-degree angles. Now I just got to do that with my other points. 2, 3, 4, 5, 6. So then go 6 on the other side. 1, 2, 3, 4, 5, 6. So there will be that point. Last one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8 to get to your point. So then there would be your triangle reflected over the line y equals x, the diagonal line. If you would fold it over on that purple line, those two triangles would match up perfectly.